This is section 17.1, and we're going to be dealing with functions of several variables. So sometimes you need more than one variable to model a situation. For example, in our notes, we're talking about the price of an item. That might depend on a lot of things: time on the market, competing items, labor cost, demand, etc. And so sometimes you need to put more than one variable in your function. Example, a company produces X items at the cost of $10 an item. Then the total cost would be C of X equals 10X. We're used to that. That's a function of one variable. However many items you have times $10 an item gives you your total cost. If a company produces two items, X of one item at a cost of 10 and Y of another item at $15 an item, what's the total cost? That's two independent variables, X and Y. So C of XY would be 10X plus 15Y. And to find the cost when X is 5 and Y is 12, C of 5 comma 12, you're plugging in. So just like when we say what an F of X is something, and if we want to know F of 3, we plug 3 into the function everywhere there's an X. So C of 5 comma 12, you put 5 where the X is and 12 where the Y is. All right. Now, we're going to do some evaluating of functions, and they're going to call them Z instead of F, but Z is F of XY. So we're given 4x squared plus 2xy plus 3 over y. Find F of negative 1, 3. And you are simply plugging in the negative 1 here for X, the negative 1 here for X. The 3 is going here for that Y and here for that Y. And you just calculate all that and get negative 1. Now, find F of 2, 0. Well, if you think about it, if the Y is 0, this piece right here is undefined. So it makes the expression undefined. So you have to look for something like that. Given F of XYZ equals, and you're given this function, find F of 2, negative 3, 1. So you're going to just plug in 4 times 2 times 1 minus 3 times 2 squared times negative 3 plus 2 times 1 squared. Do all the calculation and you get 46. So we'll do a little bit of that. Then we're going to have some graphing of functions of multivariables, and that is going to be a three-dimensional type graph. So I've shown here, if you were asked to plot these 4 points, so your grid looks like this: X, Y, and Z is the one going up. And then you have dots going up from each point or coming out from each point. And the positive for X is where the grid is. So positive X goes this way, negative X would go back this way. Positive Z is up, negative Z is down, positive Y is here, negative Y goes back this way. So when you're asked to plot 2, negative 4, 3, start with the 2. So we're coming down here, and for this point, we went 2, positive 2 on the X, then the Y is negative 4. So we're going to go 1, 2, 3, 4. We're about here. And then positive 3 on the Z means up 1, 2, 3. So there is the point 2, negative 4, 3. For 0, 0, 4 means you're not on the X or the Y, but you're 4 up on the Z. So there's that point. For 1, 5, 4, we will go 1 on the X, 5 on the Y. So 1, 2, 3, 4, 5, and then up 4. 1, 2, 3, 4. So that is how we do that one. The last one, 4, 7, negative 3. We'll go 4 on the X, 1, 2, 3, 4. We'll go 7 in the positive Y direction, 1, 2, 3, 4, 5, 6, 7, and then down 3 because Z is negative, 1, 2, 3. So that's how you would plot points in the multivariable space. Now, the region of 3D space where all the coordinates are positive is the first octant. So that's if you're asked about that, it's the first octant. So this one is graphing a function, a multivariable function. So we've got 2x plus y plus z equals 6. This is a plane. It's going to be a shaded thing. So we need the intercept. So first of all, we're going to let y and z be 0. We get 2x equals 6, x equals 3. So there's the x-intercept. Then we let x and z be 0, and we get y is 6. So there's that intercept. Then if we let x and y be 0, z is 6. So here's our 3 points that we're going to plot. And we come down to the grid, and we go to 3 on the x, put a dot. 6 on the y, put a dot, and 6 on the z. Connect those and shade them. So that's like a plane, like a piece of glass that's going right through there. That is the first octant part of a plane that is described by that. How about x plus z equals 6? Well, the same thing. Your x-intercept is 6, 0, 0. Your z-intercept is 0, 0, 6. We have no y-intercept, so let's see how that goes. We put 6 on the x, we put 6 on the z. We don't have a y, so you're going to, from each of those points, draw a line parallel to that axis. So this line is parallel to the y, and this one is parallel to the y. So we've got lines that are parallel, but we're never going to hit, so we just kind of make a curved thing like that. It doesn't have to be perfect, we're just sketching, and then we shade inside there. So the graph of a function of two variables, z equals fxy, is a surface in 3D space. You might see that terminology. All right, we only have 3 questions to really work on, so let's go look at our problems. So the problems are right here, and the third one had pictures. It did not come in with the pictures when it printed, so I have another set down below. Number 1, find the indicated value of the function fxy equals 2x plus 9y minus 7. Find f of 4, negative 2. So we're just plugging in 4 for x and negative 2 for y. And we do that calculation, we get negative 17. That's pretty simple. For number 2, our function is square root of 5y squared plus 4x squared. And we've got 1, 2, 3, 4 things to plug in. I'm going to go down here to number 2 and show you the work for those. So 5 and negative 5. So I have my radical. I've got 5 times negative 5 squared plus 4 times 5 squared. That's 5 times 25 and 4 times 25. And we end up with the square root of 225, which is a perfect square. That works out nicely. We got 15 for that answer. For b, negative 1, 4. We plug in the 4 here for the y and the negative 1 here, and we end up with 84. Well, the square root of 84 is not a perfect square. So fixing radicals, you kind of got to rationalize that. We're going to try to find the biggest perfect square that will go into 84. In our case, it is 4. So we put square root of 4. It goes in 21 times. So this is the same as the square root of 84. But now the square root of 4 is 2. So your final answer is 2 square roots of 21. You want it simplified like that. And then negative 4 and negative 4, if we put those in, it comes out even, and it'll come out to 12. So there wasn't much to show you there. Just plugging in those numbers. D part, f of 0, 6, when we plug that in, we end up with square root of 180. And again, we've got to simplify that. So 36 is the biggest perfect square that divides into 180, and it goes 5 times. So square root of 36 times square root of 5, leaves us 6 square roots of 5. That would be our answer for that one. The last question, number 3, was a multiple choice question. It didn't come up in the worksheet. Graph the first octant portion of the plane 3y plus 5z equals 15. So the easiest way to look at this, so we have a y-intercept, we'll have a z-intercept. We don't have an x-intercept. So we want to find the picture that does not hit on the x. This one hits on the x. This one has a point on the x. This one does not. So this one would be our answer. We're looking for that idea that we didn't hit the x-axis with a point. I think that's it. We're just touching on this briefly, but that should get us through 17.1.